Module 2, Lesson 5, Measuring Variability for Symmetrical Distributions. All right, in this lesson, we're going to calculate the standard deviation for a given set of data. You need to open your workbook to page 120. We're going to start with the definition. Everything that I haven't read, you need to copy down in your workbook. So standard deviation, the definition. This measures the typical deviation from the mean. What we're going to look at next are the 6 steps for calculating the standard deviation. I'm going to give you time to copy each of these steps down. The first step for calculating the standard deviation, the first step is to find the mean of the data set. Step 2, calculate the deviations from the mean. That's what we did yesterday in the previous lesson, lesson 4, which means that you take the data value and subtract the mean. Step 3, you're going to square the deviations from the mean. Squaring is when you take the answer that you get, you're going to put it in parentheses and put the little number 2 at the top, squaring it. Step 4, you're going to add up the squared deviations. Every one of these steps uses the answer from the previous step. So you're adding up the answers that you get in step 3. Step 5, you're going to divide by n minus 1. And what that means is 1 less than the number of numbers in the list. So normally when you're finding the mean, you would divide by the amount of numbers, but this time you're going to divide by 1 less than the amount of numbers. And the last step is you're going to take the square root of that answer. Square root looks like this. And on your calculator, to take a square root, you hit the second key and the x squared key. So you use 2 keys, the second key and the x squared key, and that's how you get a square root. And I'll show you that when we get working. Okay, the larger the standard deviation, the greater the spread or the variability of the data set. And that's the last sentence at the bottom of the page. And just a quick note, in your book page, actually it should be page 121. Example 1 is a complete example of how to calculate the standard deviation. It's a good example for reference if you get stuck. The rest of your notes should also be a good example. Okay, so let's turn over to page 122. And we're going to do an example together. Okay, we're going to calculate the standard deviation of the lifetimes of the 8 Grand B batteries. The mean was 100.5. We already have the deviations for the mean. This was back on lesson 4. Okay, so here's the hours and the deviations from the mean. So the first thing that we're going to work on is finding these squared deviations from the mean. You want to make sure that you put all of your negative numbers in parentheses. So very important, negative numbers must be in parentheses. If you don't put them in parentheses, you'll get wrong answers. Okay, so the first step is write the squared deviations in the table. So just a quick example of what we're doing. We're taking, for example, negative 27.5, and we're squaring it and finding out that answer. Then we're going to take negative 24.5. We're going to square that and get the answer. I'll show you what that looks like on my calculator. Remember, if you get to a screen on your calculator and you're not sure where you are, you can always do second and mode. That gets you back to your home screen. I'm going to clear out what I already have there. Okay, so I'm in my parentheses. And I'm putting negative 27.5 parentheses. And then my square key over here equals 756.25. Now to keep it simple, I'm going to go ahead and just round that answer to the nearest whole number, so 756. Came out to 756.25. I'm just going to go ahead and write in my table 756. So I'm rounding it to the nearest whole number. Okay, doing the next one. Negative 24.5, squaring it, and that one's coming out to 600.25. And I'm just going to keep rounding these to the nearest whole number to keep it simple, because these are big enough numbers. So just 600. And I want to keep going all the way down my table. And again, the negative numbers must be in parentheses. When I get to the positives, I don't need to use the parentheses anymore. Okay, so negative 8.5, whoops, got my parentheses. Negative 8.5 squared. And that one came out to 72.25, so I'm just going to say 72. Next one, negative 6.5. And that one comes out to negative 42.25, so I'm just going to say 42. I'm sorry, I came out positive 42.25. So just 42. Now I'm not going to use parentheses anymore. 9.5 squared. 90.25, so just 90. 16.5 squared. 272 when I rounded. 17.5 squared. 306 when I round it. And 23.5 squared comes out to 552 when I round it. Okay, so that's our first step. Next step, we're going to add up the squared deviations. So I'm going to take all those answers there, 756 plus 600 plus 72 plus 42 plus 90 plus 272 plus 306 plus 552. I'm going to add all of those numbers up. This is why I'm having us round to the nearest whole number. I don't usually do that, but there's a lot of steps to this, and I don't want to miss any decimals. So okay, and I got 2,690 for my total. Okay, next step, number 3, it says, what is the value of n for this data set? N means the amount of numbers so in this particular case, the amount of numbers is 1, 2, 3, 4, 5, 6, 7, 8. This was the data set that had 8 batteries. So it's 8. So that means in this case, n minus 1, that means 1 less than the amount of numbers. So that's going to be 7. So what we have to do is we have to divide, in this case, by 7. So we're going to take our answer up here, the 2,690, and we're going to divide that by 7. Okay, so I'm getting a big decimal again. Lots of decimals in this process. Let's say 28. And then the last step, this is where the square root idea comes from. Okay, so take the square root to find the standard deviation and round your answer to the nearest 100. Okay, I'm going to go ahead and take this one. It said thousandth up here, so that meant that I wanted to take that out 3 decimal places. Okay, so square root means I'm going to take the square root of 384.285. Okay, so what that's going to look like in my calculator, instead of squaring it, I said you wanted to hit the second key and the R squared key, and that gives us a square root symbol. So I'm going to type inside that square root symbol 384.285 equals, and I got 19.60. Yep, and that's taking it out to the nearest 100. And that's how you find the standard deviation. It says, how would you interpret this standard deviation? Well, 19 is a pretty large number compared to what it could be. It says, remember to give your answer in the context of this question. So this was the battery life. So in the context of this question, if you remember right what it said back here, the larger the standard deviation, the greater the spread of the variability. Well, this is a pretty large standard deviation, 19. So I would say that the battery lives are more spread out. I'm trying to think of the best way to phrase this. So the battery lives were given in hours.
The following students, please stop by in the main office. Luther Alexander,
Okay, so the battery lives were given in hours, so that would mean that this is 19.6 hours. So what that standard deviation is telling us is that the average battery life, what that's telling us is that the battery lives, they might be anywhere from 19 hours from whatever the average life is. They might be, well, 19.6, so that's almost 20 hours. You could expect a battery to last anywhere from, let's see, what was there could be a 20-hour difference between the battery life. So if they said that the average battery life, what was the average battery life? I'm sorry. Sorry, the bells threw me off. Average battery life was, oh, they didn't tell us what, 100 hours. There we go. There's the average battery life, 100 hours. See, but when you buy this battery, the battery life could be anywhere from 80 hours to 120 hours. That's how unreliable it is. Okay, so the standard deviation is pretty big. It's almost 20 hours. It would be better to have a smaller standard deviation, let's say only 2 hours, only 5 hours, for example, because then if the average battery life was 100 hours, then you would be able to rely on it more, because then you would know that it might only be off by 2 hours. Then the battery life, say, might only be 95 to 105 hours. That's more reliable. But according to standard deviation, it's telling us that average life, that might be off by 20 hours. It might be 20 hours. It might only last 20 hours less than that, or it might last 20 hours more than that. You don't know. So that's what standard deviation means. Okay, let's see if it makes more sense when we go over this one. Okay, so Jenna has bought a new hybrid car. Each week for a period of 7 weeks, she has noted the fuel efficiency, okay, how good the fuel is in her car, how well it lasts. The results are shown below. Calculate standard deviations to the nearest hundredth. So the first thing we want to do is we want to find out the mean. Sorry about the bells today. Okay, so first thing we want to do is we want to find out what's the mean. So I'm going to add up those numbers and divide. So I've got 45 plus 44 plus 43 plus 44 plus 45 plus 44 plus 43. 308. And divided by 1, 2, 3, 4, 5, 6, 7. So 44. After you do that, that's the first step, finding the mean. The next step is you want to get the deviations from the mean. That's what we did yesterday. So I want to subtract 44 from all those numbers. My recommendation is to take all those numbers and make it more in a table format, like the previous problem was, a table format with 3 rows. So if you have room in your book underneath the table or underneath the numbers, great. If you don't, rewrite them over again. But you're going to need 2 more rows. Okay, so now we're going to take each of those numbers and we're going to find the deviations from the mean. So I'm going to subtract the data value minus the mean. So I'm going to take each number, 45 for example, and subtract 44 from it. So that would be 1. 44 and subtract 44 from it, so that would be 0. 43 subtract 44, that's -1. 44 subtract 44, 0. 45 subtract 44, 44 subtract 44, and 43 subtract 44. After that, I'm going to take all of my previous answers and I'm going to square those. So I'm going to take my data value minus my mean and I'm going to square those results. Okay, remember you're supposed to put negative numbers in parentheses. So 1 squared is 1, 0 squared is 0, -1 squared is 1, 0 squared is 0, 1 squared is 1, 0 squared is 0, -1 squared is 1. Okay, so step 2 was doing the data value minus the mean. Step 3 is doing the data value minus the mean, those answers, and squaring it. Step 4, you want to take all of the answers you just got and you want to add. So I'm going to take my 1 plus 0 plus 1 plus 0 plus 1 plus 0 plus 1 and add all those answers up. So that's 1, 2, 3, 4, 4. Okay, your next step is you want to take your answer and you want to divide by n minus 1. Remember, n stands for how many numbers do we have, which we have 1, 2, 3, 4, 5, 6, 7 numbers. And n minus 1 stands for 1 less than how many numbers do you have, so that would be 6. So I'm going to take 4 and divide it by 6, which in this case is going to be 0.667 if I round it. And the last step is we want to square root that answer, that previous answer. So I'm going to take the square root of 0.667. Remember, square root is second and x squared. And that's coming out to 0.8 or 0.82 if you want to round it. Okay, in this case, that is a very small standard deviation. It's less than 1. What that standard deviation is saying, the mean came out to 44. So that's saying that in the context of this problem, which was the fuel efficiency in miles per gallon, the car's fuel efficiency, or let's just say the car's fuel is very efficient, between, if the average was 44, or the mean was 44, it would be anywhere from approximately 1 less than that, and I'm getting 1 from kind of rounding this to the nearest whole number, 1 less than that to 1 higher than the average. So it could be anywhere between 43 to 45 miles per gallon. And I knew it was miles per gallon because they said that up here in miles per gallon. That's what all those numbers represent, 45, 44, those are all miles per gallon. Okay, and that was actually the answer to this is the answer to number 6, explaining what it means. Okay, and that's how you figure out the standard deviation.